Hi, Chris Kuzmal here. We're going to be talking today about discrete math. The first thing that I think of when I think of discrete math is permutations. So if I have an apple and an orange, I could also have an orange and an apple. That's all the permutations of my orange and my apple. There's only two of them. Let's write some code to do just that and inkle about what might be beyond. So I'm interested in producing all the permutations. So here I am in REPL. I'm going to write a function called permutations. In order to define it, I have to put the keyword def in front of it. And I'm going to have a permutations of some list. I'm going to call it my list. Okay. Now then, if my list's length is less than 2, I'm just going to give back a list that contains my list. So in other words, I'm going to have a return value, which is an empty list at the beginning. And then I'm going to put into that return value each of the permutations of my list. And if the length of my list is less than 2, if it contains nothing, or if it contains one element, then there's only one permutation of nothing, which is nothing. There's only one permutation of one thing. The apple is an apple. Okay. So a list of apples is list of apple is an apple. List of apples, I don't know what to do about that. Let's not worry about that. That's a complication. So if the length of my list is less than 2, then, and then I have a colon, then I indent, and I'm just going to have retval append my list. All right. And if the length of my list oh my gosh, that's right. If the length of my list is exactly 2, then I'm going to build up, I'm going to create a new list, which is my added list, or R list, or reverse list, is just going to be a list that contains my list of 1. The 0th element of the reverse list is the element number 1 of my list, followed by my list of 0. Okay. And now what I can do is retval append my list and retval append the R list. So there's only two possible lists of two things, two possible permutations of two things: the original sequence and then the reverse sequence, which I explicitly coded on line 6. And so that's all I've got. I'm going to return the return value. Okay. And the cool thing about Python is, right in my code here, what I can do is now I can create a test list, which is going to be, say, contain 3 and 4. And then, oops, test list is equal to 3, 4, not test list with brackets 3, 4. So test list is the list 3, 4, and then I'm going to invoke permutations on my test list. Permutations. Why isn't it happy? It's because I misspelled the original definition. I spelled it permutations, and now it's happy. So now I should be able to run it. I don't expect any output, but I don't expect any errors, and I don't get any errors. And so then if I can print them, the nice thing about Python is it tends to be nicer about printing things. It prints 3, 4, 4, 3 lists, 2 lists. I have produced all the permutations of a list of size 2. Now all we have to do is generalize this to more than a list of length 2. But that'll be for future videos. Or you can do it on your own. Good luck.